Hi, we're going to do some practice with properties of exponents. The first thing I want to talk about is if we are multiplying two expressions that have the same base, x cubed times x to the 10th. When two expressions have the same base, you keep the base and then add the exponents. That's one situation. Another situation could happen if we have different exponents with different variables. What we would do in that situation is we would copy down the same base and add those exponents. Then we would keep the y cubed just to make sure we don't change the value of the original expression. Another situation that could happen is we could have expressions that have coefficients in front of the variables. And if that's the case, we're going to take this step by step. The first step is to multiply the exponents. 10 times 2 is 20. Then we're going to multiply the expressions with exponents. So we'd keep the base of x, and then we would add the exponents. Now, the reason for doing this is because the definition, let's see if I can erase this stuff. What is an exponent anyway? Let's see, select text. Next, we would have the powers of products. Now, when you have powers of products, what that means is we're going to have an expression, let's say 2x, and that's a product because it's 2 times x, and we're going to raise that to a power. Well, this exponent means take the base times itself 3 times. Well, when you expand it that way, look what we have. We have to multiply our coefficients first, then we'll multiply the variables. So powers of products, let's say we have a half x to the 5th, y cubed, and then that whole thing is being raised to the 4th. Well, we're going to have to think about it like we're going to take a half times itself 4 times. Then we're going to take x to the 5th times itself 4 times, and then y cubed times itself 4 times. A half times a half times a half times a half, we would end up with 1/16 times x to the 20th times y to the 12th. Another situation we might have is we could be dividing powers. For example, if we have x to the 4th divided by x squared. Well, one way to figure this out is to expand. X to the 4th means x times itself 4 times, and x squared means to multiply it by itself 2 times. Well, if you think about it, what's x divided by x? 1. What's x divided by x? 1. So how many x's are left over? we've got x squared. But another way to think about that would be to say, if we have x to the fourth and we're dividing it by x squared, since our two expressions have the same base, we'll keep the base of x, but then we will subtract the exponents. If we have the power of a quotient, that means we have a division problem already, but it's being raised to a power. Well, again, that exponent of 3 tells us to take our base and multiply it by itself a certain number of times. So if you think about it, after expanding it, we would get x cubed over y cubed. So basically, the exponent is going to be given to each numerator and denominator. Another example like that would be 3 over y squared, and that whole fraction's being raised to the fifth. Well, 3 to the fifth would then be divided by y squared times y squared times y squared. Do that 5 times, and that would be y to the 10th. If we have an expression, say 5 divided by 5, we know that that equals 1. Well, what if we had x squared divided by x squared? That would equal 1. But previously, we learned that when we have a quotient of powers, we keep the base and we subtract the exponents. So in this way, we can tell that any number raised to the 0 power equals 1. Y cubed divided by y cubed would equal y to the 0, which equals 1. Z divided by z equals z to the 0, which equals 1. 1,000 divided by 1,000 would equal 1,000 to the 0, which equals 1. Now it's almost your turn to practice on your own, but I thought we could do at least 4 mixed practice problems together. So number 1, look what we have. We are multiplying 3x times 4x. So we multiply the coefficients first to get a 12, and then x times x is x squared. For number 2, we are multiplying x cubed times y squared. Well, you know what? They don't have the same base. So x cubed y squared is simplified. Number 3, we are starting with a fraction or quotient, and it's being raised to the 4th power. So that means we're going to take x cubed to the 4th divided by 2 to the 4th. So that would be x to the 12th divided by 16. And the last one, I don't think we talked about this yet. The fact that look at the coefficients. We better do the regular division there first. 300 divided by 30 is 10. X squared times or divided by x squared is x to the 0. But that's the same thing as saying 10 times 1, which is just 10. We might run into a situation where we would have a power, x to the 4th, being raised to an exponent. And what that means is we're going to take that base of x to the 4th times itself, however many times the exponent tells us. So in this situation, x to the 4th squared equals x to the 8th. There's a pattern that's going to happen here each time. If we take a cubed, for example, squared, you take that base a cubed times a cubed, and the answer is a to the 6th. But if you look at what we originally started with, 3 times 2 equals 6. 4 times 2 equals 8. So when we are finding the power of a power, we are going to multiply the exponents. So if we had 3 to the 5th and we raised that to the 10th power, that answer simplified as a power would be 3 to the 50th.